Hi friends, thank you for joining in. Could you please confirm if you're able to see my screen right now so that we know that everything is technically working well? So could you please confirm that? Again, you should be able to see the chat window, and if you can, so that we know that yeah, I can hear my own video feed coming back to me. So I'm hoping there are no technical glitches in terms of streaming itself. So could you also confirm it from your end, please? You can see the screen and you can hear my audio clearly, right? Okay, so here is some notes that we have written, and we'll share the notes at the end of the discussion, right? So let's wait for, again, I try to join a little early just so that if there are any technical glitches, we can fix them as we go, right? So thank you very much. Thank you, folks. Thank you for joining in. We'll start the session at sharp 7 p.m. So please be patient. Again, we'll try to spend about 60 to 75 minutes. I have a bunch of notes with a lot of links, examples, concrete ideas, and screen is not visible. Okay, I think I am, just let me see. The screen should be visible, right? I mean, I have opened the chat window, so okay. So hey folks, thank you for joining in. Thank you for joining in, and let's get started. It will start at 7 p.m. So we have 3-4 minutes to go. Okay, cool. Okay, no issues. Good. So again, what we try to do is, I have written some notes. I'll share this whole document, this PDF itself. I have a lot of notes here with a lot of links, types of problems and things like that. I'll go through this in detail, line by line. And the plan here is that we'll spend about 60 minutes again, we'll see how it goes. Okay, so we'll take this whole discussion in 2 phases. First, I'll explain the notes that I have because it would cover most of the questions you folks might have. Then after we finish the notes, we'll go for Q&A. Again, during the Q&A session, I'll just go through the comment section and I'll try to answer as many questions as we can. But please understand that since this is a public session, it's very hard to answer every question. Okay, so first I'll go through all the key points that I have in the notes. Don't worry about taking notes because this whole notes that we have, I'll share the PDF of it at the end of the discussion. So don't worry about taking notes. So we'll do it in 2 phases. First, I'll go through all the key points. Then we'll open up the floor for a Q&A. Right? So that's how we'll progress here. Okay, so let me see. Okay, there are a bunch of questions here. Okay. Again, we'll surely try to answer some of these questions in the second part of the discussion itself. Right? So we'll do that. Don't worry about it. Again, we'll try to focus on software engineer roles at product-based companies in this discussion because that's the title of the whole topic itself. Probably we'll conduct one more session about data scientists or machine learning engineers, or we could do some videos also, right? So for this, let's keep the focus to software engineer roles, right? So since some of you are asking for data science and machine learning roles, if you apply for data science or machine learning engineer roles, if you come from computer science background or if you have software engineering experience, you can expect one interview which is very similar to a software engineer role. Typically 1 or maybe 2 interviews, typically 1 interview, right? Sometimes you might have, for machine learning engineer roles, you might have 2 interviews also, which focus primarily on programming data structures algorithms, especially if you come from a computer science background or if you have worked as a software engineer at any company earlier. Right? Otherwise, they don't have these rounds. Suppose if you're an electronics student or a mechanical engineering student, they'll have some programming round, but nothing to do with data structures and algorithms much, except for some very basic stuff. Okay, so let's get started since anyway we are almost there. Okay. Yes, somebody is asking about some key questions, how to practice all of that. We'll share this in this document itself. So don't worry about it. Okay, we have a lot of links, publicly available links that you can prepare from, especially in this 100-day program, right? So let's get started, folks. Thank you. Again, thank you everyone for joining in. As I was just explaining students or participants who joined little earlier, we will follow two stages. First, I'll explain all the notes that we have pre-compiled. Again, this notes has been created by all of our team at our interview prep course. You can find more about our interview prep course at interviewprep.appliedcourse.com. We have a phenomenal team that has studied how to help people crack product-based companies, especially for software engineer roles. And we have helped students prepare in 100 days. So this is one such example. Again, you don't have to take notes. I'll share the PDF of all of these notes at the end of the discussion. After I finish going through the notes, we'll open up the floor for a Q&A, and I'll try to answer as many questions as possible. Since this is a public live session, I may not be able to answer all the questions, but I'll try to answer wide spectrum of questions. Okay, so let's get going. Okay, so again, the objective here is very simple. I will primarily focus on software engineer roles at product-based companies in 100 days. Those are the three things. Okay, so let's get going. First and foremost, what resources should you be using? Again, there are a lot of phenomenal books and websites. I'm listing our favorites. Introduction to Algorithms by Corman, Leazars and Rivest and Stein, often called as a CLRS book. This is one of the best books in the world that we know of to learn data structures and algorithms. One of the best books, right? This is used as a standard textbook at some of the world's best universities. I still have a copy of this book from my undergraduate days. It's a book that I personally love. And again, you can follow any major book by any major author, but if you don't have a favorite author or a favorite book, this is a great book, right? As far as practicing problems, there are tons of sources. There is LeetCode, there is HackerRank, Codeforces, CodeChef, Geeks for Geeks. There are tons of resources. One of the biggest problems is there are so many resources that it's very easy to get confused because this feels like an ocean of questions, right? So we will help you understand this ocean of questions and how to prioritize your preparation. From our personal experience, LeetCode is one of the best platforms that we know of. Again, this is our personal preference. Some of you might like other platforms also. Okay, LeetCode has a vast majority of good problems and a very nice interface where you can practice problem solving. Again, what we recommend is if you're an average student with average aptitude and problem solving skills, you should try and approximately solve about 500 problems in these 100 days, right? So approximately about 500 problems. Again, some of you who are bright and brilliant might just require 150 to 200 problems. Some of you who are below average might require more problems, right? So on an average, if you think about it, in this 100-day program, on an average, you'll be solving about 5 problems per day. Again, I'm talking only about averages, but typically what will end up is there will be some hard questions, some easy questions. You can do 10 easy questions in a day, but you might only end up doing 2 or 3 hard problems and things like that, right? So one of the objectives of this is there is an ocean of resources. How do you prioritize and how do you prepare? That's the core objective here, right? So I hope there are no technical glitches. Okay, cool. So let's continue since there are no technical glitches that I see here. Okay, we'll break learning into multiple phases. The first phase is recap of programming. Again, in this 100-day plan, we are assuming that you know some programming language. It could be C, C++, Java, Python, Ruby, JavaScript, doesn't matter. We are assuming that you know at least one programming language. So we will spend the first 3 days recapping programming or the fundamentals of programming with some practice. Again, we'll only practice simple problems here. Then we will spend almost close to 54 days, right? A large chunk of time understanding concepts in data structures and algorithms and solving some of the easier problems. Again, when I say easy, medium, hard, okay, we'll categorize problems into easy, medium, hard. This is the same categorization that you'll find on LeetCode, which is one of our favorite platforms. And by easy, again, what is easy for one person may not be easy for others. So we'll use the tags of easy, medium and hard as given in LeetCode practice problems. Again, we'll give you links to tons of interesting and well-structured problems for practicing, right? So when you're learning concepts, please don't just read the concepts. Please also solve some of the easier problems in these 54 days. Again, we'll go to each of the major data structures, each of the algorithms, and how to utilize this 56 days roughly. Then, so the first phase is recap of programming. Second phase is learn the concepts, solve easy problem. Next 30 days is just problem solving. In this phase, you'll try different patterns of problems. Again, what many people do is they solve similar types of problems, which is not teaching them new skills. You have to solve different patterns of problems. We'll show you some nice examples of some different patterns with examples. I'll explain all of that in the coming notes, right? Or in the future slides in this session itself. So you can spend about 30 days. Again, here you will be solving a few medium and some hard problems also. Again, you can spend anywhere from 30 to 40 days here because the rest of the topics are simple. There are a few advanced data structures on which you can spend about 5 days. Again, I list all the advanced data structures. Again, you don't have to know all of them, but knowing them certainly helps you in product-based companies. And there are a bunch of miscellaneous topics like NP completeness, NP hardness, etc. You can spend a few days on this, right? So this is the 100-day plan. This is the high-level phases of learning. First, programming, concepts and easy practice problems of core data structures algorithms. Then about 30 to 40 days of pure problem solving. Again, have a few days for miscellaneous and advanced data structures. Okay, that's a broad idea. Now let's dig into it. Again, whenever I say please write code, again, we see a lot of people doing this mistake. Always, whenever we say solve a problem, what we mean is write executable code. First, read a problem statement. Think about the logic on how you will solve it using all the concepts that you have learned till now, or if possible, write pseudocode, right? Or something. If you prefer writing pseudocode, write it on a piece of paper or just think about the logic. Then you should think about time and space complexity. Lot of students stop at this phase. Okay, they read the problem statement, they think of the logic, they think of time and space complexity, and they stop here because we humans are lazy, right? We don't want to put in the extra effort. But you have to code it up. Please code it up in any language of your choice. It could be Python, Java, C++, C, or any other major language. Please don't skip this step. And while you're coding things up, please handle all the boundary cases because this matters a lot for product-based companies. Even if you write code which is not time complexity or space complexity optimal, that's okay. But because you're joining mostly as a fresher, like an SDE 1, right? But handling all boundary cases is mandatory, right? So when I say solve a problem, these are the 5 steps that you should not miss. Please don't stop in between because if you do it, you're not learning all the skills that are actually needed in the interview. Cool. So let's go to the next, so one second. Okay, so day 1 to 3, let me give you a quick recap of what you need to focus on. Again, whatever programming language you pick, stick to it. Okay, whatever programming language. So if you're picking C, C++, be very good at pointers. This is where you can encounter questions. So we are assuming that you already know a major programming language. So please, if you're picking C and C++, focus a lot on pointers because this is where people will make mistakes. Next, if you're picking C++, please also learn the standard template library, which has some of the most important and basic data structures, right? Like a hash table, trees, sets, all the major data structures are in STL, right? So please don't skip STL if you prefer C++. Again, C++ is the preferred language of programming for finance companies like D.E. Shaw or Morgan Stanley, right? So some of these companies specifically ask for C++ programmers, right? On the other hand, if you look at internet companies or other product-based companies, they don't care so much about which language you're using. When I interviewed for Yahoo Labs, I mean almost more than a decade ago, I wrote code in C. I said, sorry, I'm not very good in programming, but I know data structures. I can write C code. I'm not good in all the other languages. And the interviewer said, feel free, write code in C, execute it and show it to me. That's it. So it doesn't matter. Most internet and product-based companies, they're very open-ended, but finance companies can ask you to write code in C++. One of our favorite programming languages is Python, primarily because of its simplicity and because of its applicability in a wide spectrum of things. Python can be used everything from building websites to building machine learning models. Again, if you choose Python, please revise all the key data structures like lists, tuples, dictionaries, sets, all of them, and learn the basics of object-oriented programming. You don't have to know object-oriented design, but you have to know the basics of object-oriented programming. That's very important. Again, we see a lot of people also preferring Java, which is a very good language, which has very good inbuilt libraries, which already implement key data structures, just like STL for C++. So please, if you pick Java, recap all the libraries that have the basic data structures and recap basics of object-oriented programming. Again, you have to become comfortable with syntax, right? Again, if you prefer Python, here is a very nice link that we have. Again, I'll open this link and show it to you. Our recommendation is in these 3 days, again, we'll give you a recommendation from a Python perspective, but you should be able to find something similar in Java and C++ also. Or you can look at problems here and solve them in C++ or Java. It's up to you. If you prefer JavaScript, that's also okay. Doesn't matter, right? So if you want good practice questions, Adabit is a very nice website with lots of problems. Our recommendation here is, again, Adabit has problems which are easy, medium, hard, etc. If you're a non-CS student, if you're a non-computer science student, start with easy problems on Adabit. I'll show you Adabit in a while. If you're a CS student, or if you have prior software engineering experience, please start with medium problems and practice at least 50 problems in these 3 days. Again, these are not problems involving data structures algorithms. These 50 problems will help you become comfortable with the basic programming structures in any language of your choice. Example, let's assume you pick Python. It will make you comfortable writing Python code, right? So again, you might say, okay, 50 problems, 3 days. These are simple problems. These are not hard or very hard or even medium problems, right? If you're a CS student, you should comfortably able to solve these medium problems. For example, if you go to this page, Adabit challenges. Okay, so you'll get a bunch of problems here. It's taking a while to load. It's quite fast. Probably my internet has a little bit. Again, I'll share this whole document, so don't worry about taking notes here. Okay, it's taking a little while. Again, you can always, okay, it's there. So you can pick any language of your choice. Let's say you choose Python. You're very easy, medium, hard, very hard, and expert. If you're a non-CS student, start with easy problems. Just solve top 50 problems that are here, right? Or if you're a CS student, please start with medium problems, right? So it's as simple as that. This is a very nice interface. Again, they have thousands of problems. Don't get caught up in that. Just solve 50 problems so that you get comfortable with the syntax of the language that you've chosen, right? So don't solve thousands of questions here. Okay, next. On day 4, try to become comfortable and recap these concepts of algorithmic complexity. Okay, so you have to understand these 3 notations. Again, there are many other notations also. You have to become comfortable with big O, theta, and omega notations. Okay, most people use big O, but it's also, some interviews could also focus on theta and omega notation, especially if you come from a CS background, right? Again, for simple concepts, try to understand the time and space complexity. For example, if you have a simple for loop, what will be the time and space complexity? If you have nested for loops, like you have a for loop within a for loop, or you have a for loop within a for loop within a for loop, right? Again, just learn the concepts here. We will practice enough questions as we progress through as we progress through this whole 100 days, right? Again, for loops which have breaks, they'll have some conditional statements like if, and they'll break. So it's very easy to construct an example where you have a for loop within a for loop which is not quadratic complexity, right? So just be careful to look out for it. Very, very importantly, please understand how to compute time and space complexity for recursion problems. Very, 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 very important. In recursion, you should learn about the tree-based recursion method and master theorem. These are extremely useful. Again, recursion is the foundation of all of dynamic programming, right? So you have to become comfortable with computing the time complexity and space complexity of recursive equations. Again, very common mistake that we see is when people compute space complexity, you should always ignore input and output space. Many people don't They count either the input space or the output space in the time complexity. It's a very common mistake that we see people committing, right? Again, just learn these concepts. Again, you can use a book like CLRS, right? It's a very nice book which explains these concepts very beautifully, right? Again, the objective here in one day, just learn these concepts, just think about how time and space complexity will work in these cases. We'll encounter tons of examples. We'll compute time and space complexity for almost 500 problems that we'll solve by the end of the 100 days, right? So don't just learn the concept. Next, these are the 5 major topics in basic data structures, right? So you have arrays, linked lists, stack, queue, and strings. So here you have close to 20 days and 5 topics. So please try to spend 4 days per topic. Now, in these 4 days, what should you learn? Right? You should learn all the key operations for each of these data structures. For example, if you have stack, pop, push, implementation of a stack using an array, implementation of a stack using a linked list. These are some of the, again, you have to learn the key operations. You have to learn how to implement them from scratch. Again, some of them may be already implemented in the programming language of your choice, but it's important to understand how to implement it in scratch in the programming language of your choice. Very importantly, you should know when to use which data structure. Okay, so 3 things: implementation, the key operations. For all the key operations, understand time and space complexity, when to use what. So you have 4 days per topic. In these 4 days, learn the concepts, learn the operations, try to implement a stack using, let's say, an array. Try to implement a stack using linked list in the programming language of your choice. Once you're done with it, for every concept here, please practice 15 problems. Again, practice easy problems. Let's not go to medium and hard problems right away. Let's start with easy problems, 15 problems for each of these data structures. Remember, you have 4 days per topic. So this is quite good amount of time. Again, I'll provide you some links on where you can pick up these problems. So in the next slide, so let's go here. So just go to LeetCode. LeetCode tags all the questions. So again, you can just Google search for it, but we provided the links to be clear. LeetCode tag array. So this will give you array problems. For example, if you just go there, let me just open it up. So if you just go here, right? So LeetCode, just sign up. Again, you don't have to be a paid member. They have phenomenal. So you can sort by difficulty, right? Just take some easy problems. Again, pick up some random easy problems. Try to solve 15 of them for every topic. So these are all the questions on arrays, right? So just solve. Let's start with easy problems. We can always go to harder problems later. Again, a lot of people directly jump to hard problems. Please don't do that. So you have 4 days to learn the basic operations, basic implementation, when to use which data structure, and to solve 15 easy problems which are listed here. LeetCode is a very good platform with tons of problems. Don't get bogged down in the enormity or in the ocean of problems. Let's go structured here. These are the 5 most important topics that you will encounter in every product-based company interview. Okay, let's start with easy. Next, from day 26 to 40, right? The next step is, let's focus on core algorithms. Sorting and searching algorithms. Again, these are very, very simple stuff. Try to learn all the basic algorithms. If you're using CLRS, they have phenomenal explanation of searching and sorting algorithms. If you're a CS student, I'm sure you have learned this. You can recap all of them in 3 days. Okay, learn each of these algorithms, and when you're learning them, try to practice. Please try to practice implementing the algorithm from scratch. Okay, for example, imagine you have quicksort. Again, you can write quicksort algorithm in Python in about 15 lines. The implementation is not rocket science. Okay, you can write it in 50 to 20 lines, even if you handle all the boundary cases gracefully in Python. Right? So any algorithm that you learn, please try to write the code on your own. That's very, very important, handling all the boundary cases. Then again, I'll give you links for each of them where to practice questions for. First, learn the concepts from a good textbook and just implement each of them from scratch. Then you have this whole area of divide and conquer algorithms, which primarily use recursion, right? Simple recursion based problems, very, very important. Please practice that. Then you have greedy and DP problems. Again, Lot of people directly jump to DP or dynamic programming problems. But remember that if you know recursion, if you understand recursion, DP is a cakewalk. Even within dynamic programming, the hardest part is to break the problem into a recursion problem. Because once you break it into recursion, finding the optimal substructure, right? Finding overlapping subproblems. What is dynamic programming? You have optimal substructure, which is nothing but recursion, plus overlapping subproblems. Overlapping subproblems is trivial to observe. The hardest part in all DP problems is the recursion. But recursion you learn in divide and conquer in greedy algorithms also, right? So in these 15 days, focus on these. Again, if you can finish the earlier, again, remember that by the time you come here, you have had lot of code that you have written, right? Again, remember that we are giving more time for these because you can expect more questions on these, right? By the time you complete all of them, you're already in a good routine of learning and moving fast. That's why we are giving slightly less time here, but we'll solve a lot of practice problems on these topics when we go into the problem solving stage, right? So on all of them, for each of these, please solve about 15 to 20 problems. Again, I'll give you the links in the next slide. Okay, learn the concept. If you can implement it, implementation is no more than 20 lines if you choose a programming language like Java or Python, right? So again, please focus only on easy problems in this phase. Again, you have a bunch of problems on LeetCode on searching. You have a bunch of problem on sorting, on greedy algorithms and DP problems. Try to solve about 15 to 20 problems. Again, you have about 15 days, right? And you have 4 topics. Even if you solve 20, it's about 80 questions, right? Roughly about 5 questions. But by the time you reach day 25, you've already been in this process for 25 days. So you'll be able to solve it faster. On day 0, your speed will be terrible, but as you progress through it, your speed also will improve. Next, from day 41 to 60, try to focus on other very important data structures. For example, trees is a very, very important topic. Binary trees and binary search trees, AVL trees or balanced binary search trees is something that is not often asked, but it is good to know. But please spend most of your time. You can spend roughly 7 days just on these topics, maybe 1 day on this. Just understanding AVL tree, right? Again, I'll give you practice problems and all of that. Trees is one of the most important problems. Again, we'll explain a bunch of very important problem patterns in the next slides. Then you have heap. If you know tree, heap is a very simple concept, especially because you would have learnt about it in the context of heap sort also, right? Then you have hashing, one of the most popular and most widely used data structure in the world. Okay, graphs, I'll cover what topics in graphs are more important because graphs can feel like a very, very big topic. Most graph problems that you will encounter in product-based companies will revolve around depth first search and breadth first search. There are tons of algorithms in graph theory, right? For everything from basic traversals to min-cut, max flow, all of that stuff. But most interviews that I have seen, that I have been part of as an interviewer or interviewee, they mostly focus on BFS and DFS. Mostly. Okay. Then there are basic backtracking algorithms. Again, all these topics are in and around trees and graphs. Okay. Again, you have 15 days. Try to practice at least 15 problems per topic. Okay. And it's possible. So you have again, we have given the days here so as to imply which topics are more important, right? So please focus a lot on trees. You can be asked a few questions on graphs, but they'll mostly be on BFS, DFS. Mostly, not all, mostly. Okay. So if you want to practice problems, again, try to solve about 15 problems on each of these topics, or better still, try to focus it this way. Try to solve at least by this time, you should start solving about 4 to 5 problems per day. Okay, try to solve, even if you do 3 problems, that's okay. So if you're solving even 3 problems on trees, you're almost solving 24 problems. On heaps, you're solving 6 problems. Again, just focus on easy problems at this phase, because this is a phase where you're learning the basic concepts and you're practicing. Just focus on easy problems right now. Don't go for medium and hard right now, right? So these are all the links. Just try to practice as much as, again, remember, look at graphs. In graphs, the most important topics are depth first search and breadth first search based topics. Those are the most important topics for product-based companies. While there are a ton of other algorithms, try to focus on these rather than others. Okay. So from day 61 to 90, this is the second phase, right? Where you have learned all the basic data structures. You have revised your programming. You have solved all the easy problems. This stage, we focus purely on problem solving. You can spend from 61 to 90 or even 61 to 95, right? Because the miscellaneous and other advanced data structures, you can spend anywhere from 5 to 10 days. So try to spend 30 to 35 days, maybe even 40 days on problem solving only, right? It's very, very important. This is a common mistake that we see because there is an ocean of problems. People repeatedly solve the same type of problem again and again. It is very important for you to look at patterns of problems. Okay, I'll explain you what a pattern of a problem is with some examples just in a couple of minutes, right? So for example, there is this pattern called as fast and slow pointers based approach, right? So this is a very interesting strategy that you should learn, and you should try to solve problems using this strategy. So, or strategy or pattern, right? So it's very important for you to make a note of all the patterns that you are solving. Please don't solve the same type of problem every day. Okay, maybe one day you solve a problem of fast and slow pointers, other day go for a different pattern. It's very, very important that while you're learning, you're exposed to a wide set of problem patterns, so that these patterns are what will help you eventually. Because when the interviewer asks you a question, if you can map it, if you can map that question to a pattern that you've seen earlier, right, then you're done, right? So a very, very common mistake is people solve the same type of questions over and over. Please don't do that. For example, take this pattern called fast and slow pointers. You can solve about 2-3 problems on this. Again, there is something called as a linked list cycle, middle of linked list, happy numbers. There are some examples. Again, if you want to see a problem on LeetCode, just say linked list cycle LeetCode. Just Google the problem name here and LeetCode, you'll get a link on LeetCode, right? So try to pick patterns like this. I'll explain you some more patterns in the next few slides, but try to pick a pattern like this, solve 3-4 problems on that. Maybe 2-3 problems also will do. And when you're writing notes, please make notes of different patterns that you're observing. There are about 25-30 patterns that are very important for product-based companies. Again, it's not always necessary that every problem that's asked will follow this pattern, but this is where you'll see 90% of your questions from, right? So this is one. Again, other very important pattern is using 2 pointers. Again, here are a bunch of examples of problems, right? Again, all these problems require you to have 2 pointers or 2 indices that you maintain, and then you solve these problems very easily. Solve 3-4 problems of this type. Again, from day 61 to 30, again, some of these problems are medium, some of them could be even hard. That's okay, because you're done with all the easy problems. Now comes the actual problem solving practice itself. Similarly, there is another pattern which is in place reversals of linked lists, right? You have to reverse a linked list without using a lot of additional space, and you have to do it in place, right? Like reversing linked lists, reversing sub lists, reversing every n element in a sub list. Again, for all these problems, you can type the problem statement and LeetCode, you'll get a bunch of problems. Try to solve 2-3 problems in every pattern and make a note of this pattern. For example, there are a lot of problems which can be solved just using this BFS pattern, like zigzag traversals, level order traversals, connect level, all this stuff, right? So again, BFS is similarly DFS is a pattern. Okay, all these problems you can solve very easily if you know DFS. You just need to modify the depth first search that you learned in graphs to solve these problems. Again, you can expect problems very similar to this in the real world of actual interviews at product-based companies. A very popular approach is using Bitwire XOR. It's one of the most ingenious problem patterns that we have encountered, right? Again, there are a bunch of examples here. Again, it's very important. Again, there are a lot of problems where, since we are used to using one heap, there are some problems which the pattern here is 2 heaps pattern. You can't solve with one heap, so you have to get a little creative and use 2 heaps. So once you solve a few problems of this pattern, whenever somebody asks you a question, you can say, hey, maybe one heap won't do, maybe I need 2 heaps for this. So at the end of the day, okay, I'll come to that anyway. There is a very important thing that I want. So again, you get there is a problem pattern called as modified binary search. It's the same as binary search with a small modification. Again, a bunch of examples here. Again, top k elements. This is a very popular pattern. Again, bunch of examples for this. There is k-way merge. Again, this is something that you learn in merge sort, but it's an extension of the merge sort merge functionality, right? Again, this is one of the very popular question pattern that we see. Similarly, dynamic programming. Okay, a lot of DP problems are very similar to the 0-1 knapsack, right? So again, here are a bunch of problems. So the pattern here is not dynamic programming. That pattern here is something very similar to 0-1 knapsack, right? Similarly, you have, the other very important thing in graph theory is topological sort. Again, which is, you can construct topological sort by using simple graph traversal algorithms. But if you know topological sort, there are a bunch of problems which are small modifications or applications of topological sort, right? You just have to recognize that pattern. Similarly, there is this pattern called as subsets, where you have balanced parentheses, subsets with duplicates or permutations. Okay, there is also this whole pattern called as merge intervals, where you have these types of problems. Then there is a sliding window type of problems, right? So again, I'll share this whole document so that you can see some of these important patterns that are very, very popular in interviews. Then there is min-max pattern, right? Again, once you're done with all of these patterns, again, we have only listed some of the patterns here. Again, these are some of the most important patterns. So from day 61 to 90, try to solve because you're only solving problems, no theory here. Try to solve 5 to 7 problems a day, right? And try to pick, again, we have listed a bunch of very, very popular patterns. Try to solve these patterns and randomly pick medium and hard problems from LeetCode and see if it falls in this pattern that you've already practiced enough. Don't go for it, right? So again, at the end of the day, most product-based company interviews are this. The interviewer gives you a problem. That problem can easily be mapped to a pattern that you know. So if you practice lot of problem patterns, there are not too many patterns also. There are about 20-25 major patterns. Again, what we have listed here are the most important problem patterns, right? So try to map it to a pattern, and since you have solved 2 to 3 problems or sometimes even 3 to 4 problems for every pattern, you can easily write code for this. Write code, handle boundary cases. That's it, you're done, right? So your practice is all about your ability to detect patterns. That's what whole of programming for software engineering roles, especially SDE1, is all about. Right? That's what it is all about. Of course, with some foundational knowledge of programming and data structures and algos. Okay, there are a few advanced data structures. Again, most of them you can find it in books like CLRS. Otherwise, there are some very nice blogs. You can even find very nice articles on Wikipedia. For most data structures, CLRS plus Wikipedia is a treasure trove, right? Again, trice, again, red-black trees, if you have time, please go through it. It's slightly advanced in the sense that just like AVL trees, red-black trees are also balanced binary search trees. Good to know, not always must. B trees and B plus trees are something that are used in databases. So if you're a CS student, you better know this. Okay. Then there are concepts like disjoint sets and segment trees. If you can learn them, great. Otherwise, just skip them. If you don't have time, if you think you want to use these 5 days for practicing more problems, that's okay. Just learn trice. That's it. That's good enough. Maybe you want to learn disjoint sets. Okay, that's also the second. So this is the most important advanced data structure. This could be the second most important data structure. Third, fourth, fifth, right? So again, I've seen a lot of interviews where people don't know red-black trees or segment trees and they've been successfully hired. It's okay. Because what companies are testing for is your ability to solve problems. Because if you have the foundational knowledge, you can always read up a book and learn about red-black tree or segment trees, right? So I've given you the importance of the order of importance of these advanced data structures. Then from day 96 to 100, just learn about these 2 very important concepts called NP completeness and NP hardness from the computational complexity theory. This is very, very important. It's important to know about it and learn about a few very standard problems, right, in the space of NP completeness and NP hardness. Okay, just learn about it. You don't have to be an expert at it. Just basic knowledge is good enough. For SDE 1 roles, you're not expected to be an expert at computational complexity, NP completeness, NP hardness. If you know it, it's good. You at least have to know the basics. You don't have to be an expert at it, right? So this is roughly the 100-day plan that we thought we'll share with you, right? Again, I'll share this whole slide deck. Very, very importantly, some students ask us, because I've just copy pasted the earlier slide, which is write executable code in how much time. So in your practice of 500 questions, roughly 500 questions is what you should try and practice if you're an average student, more if you're below average, less if you're a brilliant student, right? On an average, you'll solve about 500 problems. At the very beginning, it will take you more time, but by the end of 500 problems, what the interviewer expects is, if he gives you an easy or medium problem, not a hard problem, if the interviewer asks you an easy or medium problem, then he'll either explain you the problem, or you can read the problem statement in about 3 to 5 minutes, understand what's happening, come up with the logic in about 5 to 7 minutes. When you're coming up with the logic, you'll also be able to come up with the time and space complexity very easily. Then code it up in a language of your choice in 10 to 15 minutes. So overall, for an easy to medium problem, the interviewer is expecting that you will solve it in 20 to 25 minutes. Again, please understand that you will not reach this speed on day 0. The objective here is, at the end of 500 problems, this is the speed that you should target. On day 0, it might take you even 60 minutes to solve an easy or medium problem. That's okay. That's perfectly okay. That happens to everyone. I was in those shoes, right? What is important is sticking to the schedule, being persistent day in, day out for 100 days. It is not easy, but it is not impossible. Actually, it's fairly doable. We have seen average, even below average students stick to the schedule. Of course, some below average students took about 120 to 130 days. That's okay. That's perfectly okay. There are some brilliant students who finished everything in 40 to 50 days also. On an average, for an average student, this would take about 100 days to practice through 500 problems. Right? Roughly about 500 problems while learning the concepts. That's very, very important. Please remember the 20 to 25 minutes per problem, especially for easy to medium. If it's a hard problem, the interviewer could accept 30, even 35 minutes. Right? So again, just wanted to give a shout out to the whole interview prep course that we have designed at Applied Courses. So you can find everything about the interview prep course that we have at interviewprep.appliedcourse.com. So the way we have designed this course is keeping this 100 to 120 days schedule in mind. So we have about 90 hours of concepts where we explain everything in data structures and algorithms and basics of programming. And in these 90 hours, we primarily borrow content from CLRS. We also explain pseudocode. Again, what we do is we explain pseudocode from CLRS, we explain C code, and we also explain Python code. We provide code in other programming languages, but we explain the pseudocode, the logic itself, so that you can translate the logic to any programming language of your choice. We explain everything in both C and Python, right? Of course, if you're a Java programmer, you have the pseudocode. We'll give you this Java code also so that you can look at it. But if you understand pseudocode, understanding Java should be straightforward, right? Similarly, apart from these 90 hours of content, we have solved 210 problems. And we're daily adding more practice problems or more solved problems. In each of these solved problems, we have detailed video explanations of each of these, and we focus a lot on how to arrive at the solution. There is no point just giving you the solution. So we focus a lot on how to arrive at the solution and how to detect these patterns. And we try to cover all the major patterns that we have discovered seeing through thousands of interview questions at product-based companies, right? And we have, so the way we have designed here is after every solved problem with video explanation, we give 2 or 3 similar problems for you to practice. Sometimes 2, sometimes 3. So we have a catalog of roughly 500 to 600 problems, which are some of the most popular problems. Some of them we have solved, some of them we have given as practice for you. Again, suppose we have problem 1. Okay, we explain the detailed solution, then we give problem 2 and problem 3 for you to practice, and problem 2, problem 3 are very similar to problem 1, so that you recognize this pattern, understand it, and apply it, right? And we also focus a lot on mentorship and resolving any query you have. During the day hours, we are resolving most of our queries in 5 to 6 hours. but maximum will take no more than 24 hours to resolve any question you have, whether it's a conceptual question, whether it's about an explanation to a solution, any question. We typically solve almost 99.5% of questions that we're getting in day hours. We are solving in 5 to 6 hours, but a maximum is 24 hours, any question that you ask. And we have monthly practice and assessment tests that will help you understand where you stand, what are your areas that you're lacking, and how to improve. And when you're learning these concepts, we have also added multiple choice questions and fill in the blanks, because some companies, not all, when they have a lot of candidates that they have to interview, in addition to giving programming problems, they also give maybe 20 or 30 multiple choice questions for you to fill, or for you to solve or fill in the blanks. So we've also added a bunch of multiple choice and fill in the blank type questions in our content videos, so that students can quickly recap the concepts and understand concepts better. And we conduct mock interviews to all of our students after assessment tests once they clear the assessment tests. And as usual, as part of all of our courses, once they clear assessment tests after the mock interviews, we train them specifically for placement preparation, referring them to various companies and recruiters that we work very closely with, and we provide them job assistance. This is a 1-year course. So if you're interested, you could always consider this course, but otherwise rest of the stuff that I've given here are general. So all the resources that I've pointed to, whether it's books or websites or programming problems, everything is open, right? So feel free to follow this on your own. And if you need any help, surely reach out to us. Okay, sounds good. So let's go to the Q&A now. Okay, where is our Q&A? Cool. Sounds good. So let's ask a few questions. So let's take. Okay, so some people are answering. So the floor is open. So let's get into the discussion. Any questions that you have, please let us know. How to keep balance between preparation for product-based companies and GATE? I think I've answered this question on other instances also. Remember that GATE at its very core has about 12 subjects, which includes the subjects that are required for product-based companies. So let's write product-based companies, right? So the common thing about GATE and product-based companies is problem solving, right? And the syllabus is also common. Product-based companies expect you to write code, which GATE doesn't expect you. So if you want to prepare for both of them simultaneously, it's very doable. First, focus on all the core subjects that are in the intersection of both of them. Solve GATE problems every day. Spend about a few hours, because you're preparing for both of them. First, finish all the common subjects. Solve all practice problems, all subject tests, everything that you have in GATE for data structures and algorithms, right? Again, both of them are testing your problem solving skills. So if you're good at GATE, it's very easy. With some practice of coding, you can become good at product-based companies, and vice versa. If you're good with product-based companies, you have the problem solving ability. GATE is all about preparing a vast syllabus. That's all it is all about, right? So that's my suggestion. Okay. So what if someone isn't able to attend monthly assessment, as professionals might have time crunches due to schedule? We conduct all assessment tests on Sundays. So if you can't attend a simple exam on a Sunday, come on, that's an excuse you're giving. Again, we are not saying you should attend all the assessment tests. What we recommend our students of interview prep course is first finish the course, or at least finish a good chunk, maybe 70% of the course, and start attending these exams. These exams are all conducted during weekends at a time which is comfortable for everyone, right? Okay. 1 second. So somebody says, I'm a DB developer with 8 years. Can I start my career as SDE now? I want to get into product-based companies. Again, you can. So you are a DB developer with 8 years experience and you want to go to an SDE role. So my suggestion for you is as follows. You can always move to SDE role, but most companies will not consider you for SDE 1. They would at least consider you for SDE 2, right? Because you already have vast experience. So for SDE 2, in addition to SDE 1 syllabus, you need to know low-level design and a little bit of high-level design, right? Again, this is something that we have spoken about earlier. You can find it in the previous sessions that we have done, right? So for somebody with this experience, most companies, because most companies don't prefer to hire them as SDE ones, they would try to hire them as SDE 2s. Okay, that's what I would recommend. So competitive programming, is it important to crack interviews? Yes, very, very important. So if you're good with competitive programming, it will become very, very easy to crack product-based companies. Because what product-based companies are looking for is very similar. There is a huge overlap between competitive programming and product-based companies. So if you can start competitive programming from your first year, that's always a good idea, right? Yes, so somebody says assessment tests, you can submit them in any language of your choice, right? So you can submit for the assessment tests, you can solve it in any language of your choice, right? So that's perfectly okay. One second. Where to apply for jobs after preparation? Thankfully, we have a decent team of recruiters and recruiting partners. We typically refer you at the end of the whole process to one of our partner companies that typically interviews. Again, if you're very good, we often call the hiring manager who is hiring, if he's a friend of ours or a friend of our friends, and we ask them to consider you. And we've had students like that whom we have personally referred or via our recruiting partners that they've gotten hired, right? Cool. Do we need to do some projects? It's a very good question, Ankit. If you can, do them. Again, anyway, if you're a BTech student, it's always good. Again, in your resume, the way it typically works is this. First, you will have a phone screen where they will mostly ask easy and medium problems, right? If you do well in this, they might have one more phone screen, right? Maybe phone screen 2, or they could give you a problem and they could ask you to write the solution or type in the solution in a few minutes. Then they'll have on-site interviews, maybe 3 or 4 interviews. Some of these interviews, maybe 3 interviews, will focus primarily on programming data structures algorithms, but you could have 1 or 2 interviews, especially of the hiring manager and some senior person in the organization who would interview you, where your projects could be used to stand out from the rest. So try to do good projects as part of your 3rd year or final year of your undergrad or 1st or 2nd year of your master's program, right? So that's what we strongly recommend you do, right? So if you have projects, they certainly are valuable, but again, remember, projects only come at the very end. If you focus too much on projects, if you're not good with programming data structures algorithms, there is no point in it. So first you should prioritize data structures algorithms. If you have time, do projects, they'll help you stand out. But I've seen a lot of candidates who are good with data structures algorithms, don't have any fancy projects, they have been hired, right? So, okay. So somebody says that I have 18 months experience in a service-based company. Does interview prep course help you? Yes. So the interview prep course has been designed keeping 2 sets of people in mind. One is current undergrad, like for example, current batch BTech, MTech students. That's one target audience for the course. The second major target audience are people with less than 3 years of work experience, who have work experience in services companies or smaller product-based companies or startups. This is the 2 broad categories that we have designed our interview prep course with. Again, for those of you who are asking for SDE 2 or SDE 3, again, this is the typical target pool for SDE 1 roles, right? So we are working on creating courses for SDE 2 and SDE 3 roles. We already have designed these courses. We are working with experts in the industry. We'll be creating these courses and hopefully launching them in a few months. Okay. So are the lectures live or recorded? So the lectures are all recorded. All the concept lectures are recorded, but we constantly update the problems. So it's like a blended program. You can learn at your own pace, but we constantly update with new interesting problems almost on daily basis, right? Okay, somebody says for data science and machine learning jobs, how should you follow? Very good. My suggestion, if you're looking for data science or machine learning roles, is first become good at data science and machine learning. Many roles again, the hiring bar for machine learning and data science is first you have to become good at data science and machine learning. Then you could have one round with programming. This programming round also may not ask a lot of data structures algorithms. They'll ask basic data structures where you have to use something like a hash table or a binary search tree. So the programming bar for data science and machine learning candidates is lower than a software development engineer one, right? In most product-based companies, not all. Okay, there are companies like Google, for example. Let me give you an example of Google. Google expects whether you're a data science guy or a machine learning guy, they expect you to be very good in data structures and algorithms, especially if you come from CS background or if you come with software development experience, SDE experience. But there are other companies like Microsoft, Amazon, Flipkart, where they say, okay, we want you first to be good at data structures and machine learning. And if you know basic data structures, that's good enough. But if you are a CS student, they expect you to be good at it. So if you're looking for data science jobs, first please focus on data science and machine learning. That's most important. If you're a student who is registered for our course, we already have everything that is required from a programming standpoint for data structure and machine learning roles, right? Most of it is covered. Again, if you're a CS student who wants to crack the top product-based companies, and again, you want to keep yourself open for data science, machine learning and software engineering roles. If you're especially a CS student or somebody with software experience, you can have one interview which involves data structures and algorithms. Okay, sounds good. Again, anybody who wants to know more about the course, you can always go to our website, which is interviewprep.appliedcourse.com, right? As I've listed here. Any more details? Again, I will not be able to answer all the questions here as you can imagine. So my recommendation here is anything that I could not answer, but it's not clarified for you, feel free to email us. Just go to this website. Okay, let me just click on this. Right, so just go to this website. We have a phone number and an email address. Please try to email us here anything that I could not cover in this session. Right, so I mean that will help you. Again, I just wanted to just inform all of you. We have software development engineer internships at Applied AI course and Applied courses. This is a paid internship where we pay 25,000 rupees per month. We have 16 positions. All these are remote internships. So if you're interested, again, this whole internship program is conducted by our interview prep course, which is part of the whole Applied courses. Again, if you're interested in software development engineer internships, paid internships, remote internships, feel free to reach out to us. And please apply here, and we have an examination. We do not look at where you're coming from. We do not care about your marks in examinations. We are purely meritocratic in the sense that please apply here, write the exam, we'll interview and we'll pick candidates. Simple as that. Very often we don't even look at what degree you come from, which university you come from, how many backlogs you have. That doesn't matter. Okay, so this is a nice opportunity for some of you who knows data structures and algorithms. So please look into it if you're interested. Okay, cool. So let me try to answer a few more questions. I'll share the slideshow or else let me just do it. Right, so 1 second. Anyway, I'll just do it right after this, or else let me just do it right away. Share. I'll just do it so that people can take a look at it. Copy link. I hope it works. Let me go to an incognito window and check it once. Just give me a second, folks. I just wanted to check that the link works. 100 days preparation strategy to crack product-based companies. Yes. Okay, so let me just paste it here so that everybody can see the link to the document. Okay, so please feel free to use it. I'll also post it under this video at the end of it. So very good. Another very good question is how to constantly improve as an SDE. Very, very good question. So if you're already working as an SDE at any company, right? The first thing that you have to become good at, again, we have discussed about this in the previous sessions also, please become good at basic programming, data structures and algorithms. Once you become good at it, become good at low-level design, which typically involves object-oriented design and design patterns. The third thing that you should be able to become good at is something called as high-level design or system design or solution design. The best way is to constantly read up about these things. For example, so one thing that I do is go to major tech companies, right? So go to any major tech company of your choice. So let's say Twitter, okay, tech blog. So the technology team at Twitter, okay, so let me, Twitter tech blog, okay. So, okay, this is the engineering blog at Twitter. So Twitter writes about some of the stuff that they've built, like building Twitter's ad platform architecture of the future, okay, streaming logging pipeline. So go to any major tech company of your choice. They all have engineering blogs like this or dev blogs like this, where you can get a very good sense of how some very good engineers at Twitter build this stuff. You'll find this for almost every major company of your choice, right? So again, this is to do with some machine learning stuff, right? This is about reducing latency, right? How they reduce the search latency to 1 second. So these are some very nice blogs, especially if you're an experienced software engineer. Again, we'll try to conduct sessions very similar to this for slightly experienced candidates also, right? Very importantly, very good question. Are there any age limits to apply for SDE roles? No age limits. I've seen people, but typically SDE ones are candidates with less than 4 years experience. I've not seen many SDE ones with more than 4 years prior experience. SDE 2s can have any experience. SDE 2s typically are anybody with 2+ experience. I've seen people with 20 years experience who are software development engineer 2. Again, these are Amazon level titles. Again, typically SDE 3 is somebody with 6+ years of experience. Okay, then you will have SDE 4. These are people with 10+ years experience. So when I say plus, it means you could be an SDE 2, you could be somebody with 20 years but still be an SDE 2. That's perfectly all right. Right? So this is the typical stuff. Again, I've seen people who are SDE 3s with 20 years experience. Right? So typically SDE 1s, most hiring managers try to hire SDE 1s with less than 4 years experience. Otherwise, they'll automatically consider them for SDE 2 roles. Okay, cool. Is competitive coding required? It's not required. For example, I've never done competitive programming myself, but I'm comfortable cracking multiple product-based companies in my own career. So you don't have to have competitive programming background, but doing it certainly helps because it's a great way to practice. Okay. So I've pasted the link to the document, the PDF here. So those of you who are asking, again, I'll paste it below this live session after a while. Okay, so you have this drive dot thing, please copy it. And again, the flow of comments is so fast that it's hard for me to keep up. So Kaushik is asking, please do a course on object-oriented design and system design. We are working on it. We already have designed a course very similar to our other courses. We want it to be very high quality with great teachers, including myself, but a lot of other teachers also. Who have worked in top product-based companies for about a decade. Again, whenever we create a course, we want it to be the best that we can, right? So we take time to create a course. We take a lot of effort. We put in a lot of effort putting ourselves in student shoes to create it. So we are trying to create a course with the help of mentors, guides, people with 10, even 15 years experience at top product-based companies like Google, Facebook, Amazon, etc. So let's see. Again, it will take us some time. We do not compromise on quality. So please give us some time. We should have it ready, hopefully in a few months. Okay. SDE means software development engineer. I'm sorry. It's also called as SWE in some companies, right? SDE or SWE, right? So sorry for that. Sounds good. So again, please understand that for SDE 2 or software development engineer 2, you need to have all the skills of an SDE 1 plus low-level design, mostly low-level design and a little bit of high-level design. For SDE 3, right, SDE 3, you need to know everything in SDE 1. There is a lot of focus on both low-level design. This is the most important, but there is a lot of thing on HLD also, right? So basically, this is what it will end up being. So if you're interviewing for SDE 3, you have to be brilliant with HLD and you have to be pretty good with LLD. There will be standard data structures and algorithms interview also, right? So sounds good. Okay, folks, we've already hit our limit of 8 p.m. So it's already been 60 minutes. Again, anything that I could not answer because of the constraint of time, I don't want you guys to be waiting here for too long. So please go to interviewprep.appliedcourse.com, and any questions that I could not answer that you think are important, please email us. We'll try to answer as many of them as fast as possible. It is interviewprep@appliedcourse.com, or just leave a message here. We'll try to revert back to you. Those of you who are interested in the internship, please take a look at it. Thank you very much. Thank you, folks. Thank you for joining today. We'll conduct very similar sessions for other types of roles in the near future. Thank you very much.